Hello. Today we'll understand how to simplify rational expressions. Simplifying rational expressions is like writing fractions in lowest terms. So let's go through the process of writing fractions in lowest terms, correct? Let's say we have 8 over 12. Now how do we write it in lowest terms? We write 8 as factors of like 2 times 2 times 2, correct? And 12 can be written as 2 times 2 is 4 and 4 times 3 is 12, correct? So we get these kinds of factor. We actually first factor them. And then once we factor them, then we see which are the factors which are common in numerator and denominator, and then we cancel them out. For example, say this is common. Okay, let me cancel this out. This is common. 2 divided by 2 basically is 1, right? So we just cancel them out. Cancelling is saying 2 times 2 is 1. So 1 times anything is the number itself. So we get 1 times 2, which is 2. And then we are left with 3 here. So this is how we actually write our fractions in the lowest terms, correct? Now, if we multiply the fractions, for example, if we have something over, let's say, 9 over 15 times, so multiply, we can write a dot, or we can also write times like this, okay? Let's say we write here 35, and I've written 35 with purpose, it goes 5 in it, right? Or let's say 42. So we need not always write in the lowest terms like this to cancel them out. We have to find the common factors, right? So common factors we need to find for 9 and 15 and 35 and 42. So it seems that 9 has 3 as a fact and 15 has 5, correct? So, and 42 is like 6 times 7. So we can write 6 times 7 and 6 has 3 in it, correct? So we'll write 9 as kind of 3 times 3 is 9, right? Over 15 is 3 times 5. 35 can be written as 7 times 5 is 35, correct? And 42 is 6 times 7. And 6 can be written as 2 times 3. 2 times 3 is 6 and 6 times 7. So we factor them to their lowest terms, kind of, right? You can say prime factorization in a form, and then cancel out whichever are common in numerator and denominator. And we say, well, 3 goes with 3, that's 1. 5 goes with 5, okay. 7 goes with 7, fine. And this 3 also goes with another 3 here. So we are just left with 2 in the denominator, and so it is just half, right? So it's just 1 over 2, right? So 3 times 3 was 9, 7 times 5 is 35, 3 times 5 15, and 2 times 3 is 6, and 6 times 7 is 42. So we did all this, and this complicated thing like reduced to 1 over 2, the lowest terms. Do you see that? So this is how we were doing in fractions, correct? Now let me get to the next level of doing things in fractions, and this time let me use a different ink. Okay, so we will try to do a fraction like this where we have some addition or things involved. Let's say if I have, let's say 4 plus 6 over 4 plus 16. Okay, now a common mistake which I have seen students jump to and do it, what they will do is they say, oh, 4 and 4, they just cancel out 4 and 4, and they're left with 6 over 16, which is definitely a wrong answer. Well, you know it is wrong, since, see, let's try to add them first and then see what we get. 4 plus 6 is basically 10, right? And 4 plus 16 is 20. Well, 10 over 20 is half, correct? But we can do it in our old way, the initial way which we learned. That's a nice way actually to do it. We can write 10 as 2 times 5, okay, and 20 as 5 times 4 is 20, correct? And 4 is 2 times 2. So we can write this as 2 times 5. 20 we could have written 4 times 5, and 4 is 2 times 2. So we get 2 times, 2 times, and 5. Once we do this, we say, okay, now we got 2 common, we'll cancel this out, and we got 5 here, we'll cancel this out, and we come to our answer in the lowest terms, which is 1 over 2, correct? Well, at times, you can divide this by 10, 10 times 1 and 10 times 2. That's also correct, right? And even faster, correct? So the process is fine. So you could have done like this also, as 10 over 20. You could have done divided both by 10, and once you do that, you get here 1 and you get here 2. So you could write this as equal to half. You get the same answer, correct? But if you would have cancelled out 4 and 4, you would have got 6 over 16. Well, 16 is not twice 6. Twice 6 is 12, right? So if you were expecting 1 over 2, that means denominator twice as big as the numerator, then 6 over 12 could have been the right answer. But now I'll show you a technique of factoring and doing it using these numbers. So what you see here is between 4 and 6, we can write the factors. Let me take you to one level down. So if we can write 4 as 2 times 2 plus 6 as 2 times 3, correct? And here, because we wrote them there later, let's write them now here. We can write this as 4 as 2 times 2, right? Plus 16. In the lowest terms, I'm saying prime factorization, right? You remember doing prime factorization kind of thing? 16 can be written as 2 times 8, right? And then 8 could be written as 2 times 4, and 4 could be written as 2 times 2. So this is prime factorization. 16 is equals to 2 times 2 times 2 times 2, or 2 to the power of 4, correct? So at present, I will write just 2 times 2 times 2 times 2, correct? Well, when I do that, I find that in the numerator, 2 is a common factor, correct? So I can write 2 common, and I am left with 2 plus 3, correct? So I am factoring out 2 from this term, right? 4 and 6 has a common factor of 2. When you factor out 2, then 4 divided by 2 is 2, and 3 divided by 2 is 6. No, 6 divided by 2 is 3. So you get it like this, correct? Here, we get 2 times 2 as common. When you take 2 times 2 as common, you are left with just 1 here, right? Because you took 4 common. And here, you're left with 2 times 2, right? 2 times 2 for me is 4. But let me write 2 times 2 at present, correct? Now here, when you come to this stage, now since we have factored, it's kind of multiplication. There's no addition in between. So at this moment, we can cancel our factors which are common, correct? So this was obvious here. We did cancel it, and we get here 1 times, and it is 2 plus 3 is 5, okay? And this is 2 times, and 1 plus 2 times 2 is 4 is also 5. Good job. So we see now again we got 5 common. So 5 will go with 5, and you're left with 1. Well, if there's no other number, it's good to write 1, but not otherwise, okay? And so we land up with half, which is same as our previous question. Do you see half here? So kind of the same thing, but I'm just taking you to the next level of factoring. So we are working with arithmetic at present, where we have numbers, and we could have added them, divided, and got them into the lowest term. But we could have used this process of factoring also. Now this is kind of important concept here, because I'm going to introduce you to rational expressions from here. The only difference in the normal arithmetic fractions which we are doing and rational expression is that rational expressions have a variable. Is not just numbers. So when you have variables, you can only combine like terms, and that gives us restriction. Second is denominator. If you have a variable, it can never be 0. You know, when you write numbers in the denominator, they are never 0, right? So in fractions, we don't have any restriction otherwise. But when we talk about rational expressions, we may get a variable in the denominator, and then we have to write, well, this denominator could have any value because of the variable in it, right? So So we are a little careful and we say, well, it cannot have this value for x. It can have all other values of x, but not this particular value. Correct? So now let me take some very simple examples with you so that we can understand, move forward with this as a rational function. Correct? So let us say we have a rational function now instead of these fractions. We have 2x minus 10 here and divided by 3x minus 15, let us say. Okay, now this is a rational fraction which is just not 2 minus 10. It is not 3 minus 15. It is 2x. And that x becomes a polynomial, and 3x is another polynomial. Polynomial divided by polynomial gives us rational expression, correct? Now here we will use this technique of factoring. So how do we factor this? We see 2 is common here, right? So I can write this as 2 times, and when I divide 2x by 2, I'm left with x. And when I divide minus 10 by 2, I'm left with minus 5. Here in the denominator, 3 is common because 3 times 5 is 15, correct? So let me take 3 common, and I'm left with 3x divided by 3 is x, and minus 15 divided by 3 is minus 5. Correct. So as soon as we do this, we see there is a common factor, x minus 5. Do you see that? So we can cancel that common factor and we get the lowest term for our rational function, which is 2 over 3. So that is how we got to do a reduction or simplification of lowest terms, correct? We could not divide 10 and 15 by 5. It was wrong. If I could have divided this 10 by 5, writing it 2 and 3 here, that would lead to wrong answer, correct? Let me take some more examples here. Okay, now let's say we have something like this: x squared plus 4x plus 3 over x squared, let's say minus 1. Okay, now here remember, you cannot cancel x squared and x squared just because you see something common. There is addition operation. It's not multiplication. You could have done it only if it was a factor. What is a factor? When two numbers multiply and give the third number is a product, and those two numbers are factors. For example, 2 times 3 is 6. Then 2 and 3 are factors of 6, and 6 is their product. But when we add, we can't cancel. Only when we multiply, we can. So we'll use our techniques to factor numerator and denominator, and then if there is a common factor in numerator and denominator, that should be cancelled out. So here product should be 3 and sum should be 4. So the numbers are 3 and 1. So we get x plus 3 times x plus 1, and this is difference of square, x squared minus 1 squared. So I can write this as x plus 1 times x minus 1. Now as you can see, I can cancel out a common factor x plus 1, correct? So if I do that, I am reduced with x plus 3 over x minus 1. So this is my rational function in the lowest terms, right? Here and here, both places, we have an important thing to understand. Before we cancel it out, we should remember that denominator cannot be 0, since dividing by 0 is not possible. So what value of x will make this denominator 0? So we say, well, x minus 5 should not be equal to 0. That means x is not equal to 5. So this is called our restriction, okay? So remember, restriction. So whenever we are talking about rational expressions, you have to note the restrictions. Even before you cancel them out, you should write down all the restrictions. So here, what are the restrictions? Well, some students tend to write restriction after cancelling out the common factors, and they will land with only x plus 1, which will again be wrong. So that's the second mistake which people do. Writing restrictions after simplification. No, it should be done before it. Can x be minus 1? No. Here, x squared minus 1 is equals to 0 for both values of x, minus 1 and plus 1. Minus 1 square is also plus 1, right? Therefore, factored form gives us the ideal place to write restrictions. So once you factor it, write restrictions. So here the restriction is that x is not equal to plus and minus 1, right? Minus 1 here and plus 1 here. So this is kind of very important to understand. Writing restrictions, okay, and then writing in the simplest form. Otherwise, if I ask you a question, this is equal to this, perfect, and then we cancelled it out. This is equal to this, good job. But if I don't write restriction, is this really equal to this? Think about it. Is this expression equal to this? Well, at times, people will say yes, and that is again third mistake. These two rational functions may look like the lowest term are not equal unless and until, along with this, we write x not equal to plus minus 1. If we don't write this, then what? Then, what is the restriction in this rational expression? X is not equal to plus 1. How about this? X is not equal to plus 1 and minus 1. Do you see that? So that is a huge difference. Do you get my point? That's why they are not exactly same unless we write this restriction. Once we impose the restriction, we say, well, x is not equal to both plus and minus 1 and their domains are exactly same. Correct? Let me give you one more example. Try it yourself. And let's say x squared minus x minus 6 and divided by x squared plus 5x plus 6. Now tell me, can I cancel these 6 out? No, I can't. Can I cancel these x squared out? No, I can't. So how can I simplify it? Well, the very first step is to factor it, correct? So let's factor it, and we know product should be minus 6, sum minus 1. So 3 and 2. Which number is bigger? 3. Minus, okay? Because we want minus here. So we got x minus 3 times x plus 2, and here again product is 6 only, but the sum is 5, not 1. So 3, 2, same sign, okay? We'll add them up this time, okay? To get 5. Now as soon as you do, what should you write? Let me write restriction here that x is not equal to minus 3 and minus 2. Is it okay? Secondly, we can cancel this out? Yes, we can. So let's cancel the common factors from numerator and denominator and write our rational function in the simplest form. Does it make sense to you? Yes, it does. Now, we get this where x is not equal to minus 3 and minus 2. I hope you understand the process of simplifying rational expressions and lowest terms. We have a worksheet on this, so you can do the worksheet as a practice. Don't forget to write restrictions once you simplify. Okay? Thank you.